Zibbity zap. I like to see machine learning as a new paradigm for programming computers, where instead of just coding a solution, you can teach the computer to learn a solution. This can be incredibly useful and can open up new scenarios for you to solve problems that can't be solved by coding alone. Let's dive in. Explicit coding is the bread and butter of software developers all over the world. You think about a scenario you're working on or the problem you're trying to solve, and you express the solution by defining rules that determine the behavior of the program. For example, in this bricks game, the ball is moving along a path, which you can get changed when it hits a brick. As a programmer, you have to figure out the behavior. How does the ball bounce? Which brick do I remove? What happens when the ball hits a wall? And what happens when the bat misses it? Everything needs to be figured out in advance, predetermined by the programmer, and then coded and tested. The more complex the scenario, the more code you got to figure out. And with the law of diminishing returns, often you'll encounter scenarios that isn't feasible to figure out with all the code that you have coded down. We'll explore one of these in a moment, but first, this diagram shows coding scenarios like this one we've just explored. Traditional programming is solving a problem by figuring out and expressing rules using a programming language like Java, C++, or Python, having them act on data like the location of the ball and the bricks on the previous game, and getting answers from that. Is the game over? Does the score go up? Where should the ball be plotted next? It's really powerful, but it can be limited. Let's explore one scenario where this doesn't work well. Consider activity detection. You want to write an app that uses sensors on a phone or a watch or something else to determine a person's activity. You could, for example, use the data of their speed and write a rule that determines if the speed is below a certain amount, they are walking. You have data, you have a rule, you get an answer. Then you can extend this to determine if they're running by extending the rule. If it's below 4 miles an hour, they're walking, otherwise they're running. Great, it still works. And then you can extend it even further to see if they're biking. If the speed is below 4, they're walking. Else, if it's below 12, they're running. Else, you can say they're biking. But how would you handle golfing? What rule would you write to determine that they are playing golf? Also, by now, you probably realized that the other rules are also a little naive. You can't just go by speed. You might run downhill faster than you bike uphill, for example. Let's go back to our diagram. Recall that we mentioned in that traditional programming is where you create rules in a programming language that act on data and provide you with answers. With activity detection, we had created rules to figure out the user's activity, be it walking, running, or biking. But when it came to golfing, we hit a wall. Not only that, we can also see that our algorithm was a bit naive, right? Our rules didn't work that well. For example, you might run downhill faster than you bike uphill. So your app might fail when we have just written rules like this. Machine learning can help solve this and can represent with a simple rearrangement of the diagram. Instead of you trying to figure out the rules that act on the data to give you an answer, what if you go the other way around and you provide the answers with the data and have a computer that can figure out the rules that match them? Once this is done, you can then apply these rules to future data in order to tell us the answers about it. So in our activity detection scenario, we gather a lot of data from sensors and label them with the activity, with the user's activity as following. So now by matching parts of the data with the label that describe the activity, the computer might be able to figure out the rules for making an activity walking or running or biking. For example, I've highlighted 4 bits within each of the binary blocks. And you might notice that these 4 bits are different between the 4 activities. They could be a signal for which activity is which. With machine learning, we have some APIs that allow us to write code to potentially identify such distinguishing factors. And you'll see that a little later in this course. But first, let us consider at a very high level how this works. First, the computer will make a guess as to the relationship between the data and its labels. It does this by randomly initializing a neural network, and you'll delve into that later. But beyond the specifics, it's just simply guessing as to the relationship. Then it measures how good or how bad that guess is. The terminology often used here is loss. Higher loss is roughly analogous to lower accuracy. So measure the results of your guess. Then you get to then you use the data from the accuracy measurement to figure out your next guess, optimizing based on what you already know. And then you repeat this process, with the logic being that each subsequent guess gets better than the previous one, and your model becomes more and more accurate. It's learning from experience what the best guess is. Let's return to the diagram describing machine learning from a higher level. I've changed the word answers to labels, which is generally used for the term that describe your data, but the rest still stands. You start with labeling the data, you go through the process I previously mentioned, and you end up with a set of rules that matches that data to those labels. It constructs a model from, and from this model, you can then give it new data, right? And it will figure out how closely that data fits this set of labels, returning you a set of inferences, which are the probabilities that the data matches each specific label. Okay, so now it's your turn. In the next section, I'm going to give you a set of numbers. And there's a relationship that matches the X to the Y, a rule that you can figure out. Give it a try and think about how you figure it out. Thank you.